Here we would have it's 2 minus 42, right? And then that would give us 5x, and this would be minus what? Minus 40, right? So this would be minus 40. So we have now it's minus 40, we divide by 5, we divide by 5. And this stays the same. The inequality stays the same because we divided by a positive number. The inequality only changes when we divide or multiply with a negative number. So, but in this case, it is a positive number. So it's just x, and this cancels each other out. And this would be 8. Yes, negative 8, right? So that would be negative 8, right? And so since we have that it's negative 8 and we need to represent this on a graph, how could we do that? We could use a number line, right? We could use a number line. We could use a number line, and this is negative 8. But this is less than, so it's an open dot. And then where does it go? Points to the left, so it goes to the left. So any number that is less than negative 8 is the solution to this graph. Now, there are other ways of actually representing this graphically, right? However, yeah. So there's your answer there. So that's one of the ways of representing it graphically that you could have gone about, just using a number line, right? There is another way you could have done it, but don't do it because, yeah, it's tricky. Okay, so now we go to question 4. So I'm gonna highlight the first two. So we're gonna do the first two quickly. So the first two, the first one right there is a very long scientific notation conversion, right? So we need to convert it into scientific notation. This is gonna take some time, obviously, but we're just gonna do it quickly as possible, right? So this is a very, very small weight, or a very, 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 very small number, right? So what do we have to do in this case? Basically, we need to just count how many zeros there are and then place the comma in between. So maybe we want the answer to be 16, right, comma 75 times 10 to the exponent what? Remember, because it's scientific notation, times 10 to the exponent what? That's what we need to figure out. Now, how do we figure that out? What we should put in the exponent? Because we are moving because we're going to be moving it to the right hand side like this, right? Moving the right hand side like this would mean that basically it's going to be negative, right? But now we need to count how many times we did that. So let's do that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 8, 22, 23, 24, 25, 26, 27, 28. This is 28, right? This is 28. And this is important that you actually count it like this because this number would not appear on your calculator. Even if you put it all in, your calculator would just say math error or no, can't do it. And so this is the answer right there. Or you could have said it's 1,675, right, times 10 to the negative 27. It's still the same thing, kilograms, right? And these are kilograms. Okay. So basically you could have done it in those two ways. Okay, now we are asked another one. So given a is equals to pi, and then inside it's r minus r. Okay, r minus r. And we are supposed to make r the subject of the formula. So we first write out the entire formula as is. So let's write out the formula as is. So it's A is equals to pi, and this is big R minus small r. Okay, so we need to make big R the subject of the formula. Basically, it's just solving for R. How would you have treated this? I would have first multiplied, obviously, this inside. So it would be pi big R and then minus pi small r, like that. And that's equals to A. And then we take that onto the other side. So then that would be, let's say, this would be A my plus, because this was minus, that becomes plus r. And then we have pi r. But remember, we just want r as the subject. So then you just divide this by pi and divide that by pi. And so there we have r on this side, r that is equals to a plus pi r over pi. And this is the same thing as you could have written it like this. You could have written it as just a plus, right? Still the same thing because they are equal to each other. So swapping them around does not really make a big difference. Still the same type of solution. So there we have it. But let me maybe explain this one a bit further because some people tend to think of this as very difficult. Yet it's actually quite simple because you do this every single time when you are actually solving. The only difference is that they just put only letters, right? They only just put letters in its place. So in this case, let's change this. Let's say this was 5 is equals to 3, and this is our x minus our 7, right? Let's say, for instance, just say for fun, for absolute fun of it, that we just don't know how to multiply numbers. We don't know how to add them. We don't know numbers at all, but we know how to move things around in an equation, right? So if we know how to move things around and we just don't know how to multiply, we don't know if we say 2 times 2, we don't know what the answer is. Let's just act like we don't know, okay? So if we say 3 times that, then that would be 3, right, times x. That would be 3 times that, that is minus 3 times 7. And here then it's 5, right? You would have just calculated it and told the answer, right? But then still, because you want x on its own, so then you take that onto the other side, so it becomes plus 3 times 7. And this is 3 times x, right? And there we have it, right? Don't you think this is very similar to this point right over here when we got to this point here, right? It is extremely similar to it, right? Or not even extremely similar, it's identical, just that the the numbers and what is there is different. How we wrote it is different. So then the only thing we need to do, because 3 is multiplying x, we divide because division would cancel it out. So then it's 3 like that. And so then, as you can see, we have 5 plus 3 times 7 all over 3. And this is equals to that x that we wanted. And as you can see, where 5 was, which was in the place of A, is in the same position where A was. Where R pi is here is in the same position as where 3 is, right? And where 7 is, and so on and so on. So it will still result to the same thing. You just need to apply it the same way. So it's a very simple thing. So don't overthink it. Just because you're seeing a lot of variables and letters, it doesn't mean that it is difficult, okay? So now let's look at the last two in question 4. So here's the last one here. So the last one here, let's just quickly mark it. So then we can move it onto the other side. So we quickly mark that, okay? So now this one here is a very interesting question, right? This is what we call word problems, right? And you need to be extremely careful when you're doing them. Okay, so we have now the distance between two towns.